Okay, so welcome to the next session of the active version of the 2018 EOC standards-based review of the test. We are going to look at ACED.3 and A.REI 6, 11, and 12, where we learn how to write and solve systems of equations and inequalities. And just like we've been doing, we're going to use Desmos, which is going to be our best friend. So first off, we're looking at question number 5, and it's the three systems of equations are shown in the table below. It wants us to describe the number of solutions for each system in the appropriate column here. And notice I've already answered it. First is 1, second one is infinitely many solutions, and the last one is no solution. But the way we arrive at that answer in Desmos is going to be to simply type in the equations that we see. So taking this first box here, we have 2x plus 2y equals 16. And we're comparing that with 4x plus 3y equals 27. So 4x plus 3y equals 27. Okay, so what we're looking for with systems of equations and to define how many solutions they have is how many times they actually cross. So remember, they can only cross either once, never, or infinitely many times because they're one on top of the other. So in this case, we know that because they cross, they intersect at some point, that's going to be one solution. So we would have drug one solution there. All right, so then the next one we're going to look at is 2x plus 2y equals 8 here, and 4x plus 4y equals 16. So when we do that, we notice that it has mapped each of the lines one on top of the other. So that means that they share every single point imaginable, which makes them infinitely many solutions. Okay. The last one we're going to look at is here. We have 2x plus 3y, and we have, equals 12, and we have 2x plus 3y equals 18. All right, so if we notice the lines here, they run parallel. When lines are parallel, and we're going to just zoom out a little bit so we can be sure that that's the case. When lines are parallel, they never, ever, ever touch, which means they never have a solution in common. So we call that no solution. Hence how we arrive at these answers. Okay, let's go ahead and look at question number 10. Okay, so number 10 is a word problem, and it reads this way. Karen has 2 dogs. The larger dog weighs 1.4 pounds more than the smaller dog. The combined weight of the 2 dogs is 12.6 pounds. What is the weight in pounds of the smaller dog? Well, the fact that we're talking about 2 dogs and we need to find the weight for one when one of the weights is given tells me that I'm going to have 2 equations that I need to write. So let's go ahead and define those. Well, according to the question, it says that the larger dog weighs 1.4 pounds more than the smaller dog. And it also says that the combined weight of the 2 dogs is 12.6 pounds. So this is the important information. So we always want to begin by assigning variables to what we're looking at. So X will be our large dog and Y will be our small dog. So let's go ahead and write some equations that describe the dogs. So the large dog, X, weighs 1.4 more pounds than the smaller dog. So X is going to be equal to the small dog, Y, plus 1.4, okay? It says the combined weight of the 2 dogs is 12.6 pounds. So 12.6 is going to be equal to our large dog plus our small dog, okay? Now we're going to use any method that we like to go ahead and solve this for the small dog. So in this case, I'm going to go ahead and use elimination, but I have to rearrange my equations to do so. So the first thing that I'm going to rearrange is the equation here at the top, okay? You could also use substitution if you wanted to, where you could sub in y plus 1.4 for x here. Either way, it's perfectly fine. It's just not what I feel like doing. So I'm going to rearrange our top equation. So we have x equals y plus 1.4, and I want to get it to where my constant is on one side and my variables are on the other. So in this case, I'm going to subtract x from both sides. And when I do, for my equation here, we're looking at this. Okay, so when I do that, I'm going to get negative x plus 1.4. Oh, excuse me, negative x plus y. Excuse me on that one. Let's get the eraser going here. Okay, that's negative x plus y equals negative 1.4. Okay, all we did was do inverse operation so that we got our constant on one side and our variables on the other. And then here we have 12.6 is equal to x plus y. Okay, so with elimination, I now have a negative and a positive version of one variable, so I'm going to get rid of it, okay, and I'm going to add up my y's. So 2y is going to be equal to the sum of negative 1.4 plus 12.6. Well, I know that that's going to be really 12.6 minus 1.4, so I have 0.2 and I have 11.2, okay? So then, of course, to get my y alone, because that's what I need to solve for since that's my small dog and what the question's asking for, I'm going to divide by 2 on both sides. So my y value then is going to be equal to 5.6. Okay? And that would be our final answer for that particular question. Okay? Okay, so for number 15, it says this, oops, says two functions are shown below. We have f of x is equal to 3x squared plus 14x minus 5, and, excuse me, we have g of x is equal to 11x plus 13. It wants us to select the points at which the graphs of the two functions intersect. So here are the choices that it gave us: negative 5, 0, negative 3, negative 20, 2, 35, and 6, 79. So all we're going to do in Desmos is type in the two functions that were given. So we have f of x here. It's going to be equal to 3x squared, and I'm going to use my keyboard, so 3x squared plus 14x minus 5. And we're going to compare that with the function g of x is equal to 11x plus 13. Oops. All right, and okay, in this case, it says to select the points of the at which the graphs of the two functions intersect. I'm going to go ahead and just compare it and see what happens. So the first thing I'm going to do is go ahead and enter in my answer choices. I have negative 5, 0. I want to label that. I have negative 3, 20, and I'm going to enter that. And label it, of course. I want to enter in our answer choice C, which is 2, 35. So 2, 35, label it. And lastly, I'm going to enter in answer choice D, which is 6, 79. So 6, 79. Okay, so everything at this point is labeled, and I'm going to close this so that we can see if they actually share any of those points. Okay. So I'm going to make this just a little bit bigger so we can see it. Okay, do the two graphs share 5, 0? Well, no, it's on the graph of one function, which is our f of x, our parabola here, because, you know, that's quadratic, but it's not on our g of x function, so not an answer choice, okay? Then we're going to look at negative 3, 20. Is that on both? And let's zoom in so we can see it. Well, it doesn't appear to be on both, and I think it may be that I typed that in incorrectly. So let me just go back and check that, because I believe it should be, I did. It should be negative 3, negative 20. So always watch out for that. It is very easy to make a mistake. All right, so here we go. We have negative 3 and negative 20, and if we look really closely, that indeed falls on both, because this is g of x here, okay? And this is f of x here, and it's there. So 320 would be one of our answer choices, but we may have more than one since it says select the points. So here we go. Answer choice B, and let's look at C, which was 2,35. So let's find that. All right, and 2,35 is going to be here. Does that fall on the graph of both? We'll zoom in just to be sure, but it does indeed fall on the graph of both, because here is our red, which is our parabola, our f of x function, and here is our blue, our g of x function, and it is shared by both. So we said no to A, yes to B and C, but let's see if D is something that's shared by them. So let's go ahead and find it. That was 6,79. And all right, so here it is. Here, of course, our red parabola is f of x, okay? Our quadratic, and our blue is our g of x. Well, it's on g of x, but it's not on f of x, so that is not a solution. So B and C would have been our answers there, guys. Okay, so the last question I'm going to look at from the released EOC active portion under writing and solving systems of equations and inequalities is question number 24. And here it is. So two functions are shown below. We have f of x is equal to 3x plus 7. And we have g of x is equal to 2x plus 12. We want to know what the value of x is where the graphs of f of x and g of x intersect. So, of course, all we have to do is type it into Desmos. So let's go ahead and do that. We have f of x is equal to 3x plus 7, and we have g of x is equal to 2x plus 12, okay? And we're just going to find that intersection point. So we're going to drag our graph, and we're going to click on the intersection point. And what is that x value? Well, that x value is going to be 5, because an ordered pair is always, always, always x comma y. Once again, ordered pair is always written in the form x comma y. It's a common mistake, so please make sure that you are careful with that. So our answer choice would have been C.